Hello, this is my 11th lecture for 5th SEM DSC students numerical analysis. I, Ms. Ranjana Dutta from the Department of Mathematics, Graduate School College for Women, Jamshedpur. Today we will study how to derive Newton's divided difference formula, that is derivation of Newton's divided difference formula. As we know, suppose fx0, fx1 up to fxn are the values of fx corresponding to the values x0, x1 and xn, which are not necessarily equally spaced. Then fx1 minus fx0 divided by x1 minus x0 is known as fx0 x1 x0 or fx0 x1. Similarly, the second divided difference formula fx0 x2 comma x1 minus fx1 comma x0 divided by x2 minus x0 is equal to fx2 x1 x0. Similarly, fx3 comma x2 comma x1 minus fx2 comma x1 comma x0 divided by x3 minus x0 is known as fx3 x2 x1 x0. Similarly, fx4 x3 x2 x1 minus f x3 after that x2 x1 x0. Similarly, we call it as fx3 x4 x3 x2 x1 and x0. Finally, suppose there are fx0, fx1, fxn values are n plus 1 entry values corresponding to the argument values x0, x1 up to xn. With these n plus 1 values, we can fit a polynomial of degree n. Mind it, with n plus 1 values, we can fit a polynomial of degree n. Thus, nth divided difference is constant and n plus 1th divided difference, that is, if I take fx then x0, x1 up to xn is equal to 0. Here from x0 to xn x1 to xn there are n values and x0 is one more, that is x0 to xn there are n plus 1 values and x values which we are to find, where x is the some value other than x0, x1 and xn. As I told earlier today that x0, x1 up to xn can be written as fx x0 up to xn minus 1 minus f from the second, that is x0, x1 up to xn. See this line clear again, fx x0, x1 up to xn. This is equal to f from starting from x, we have to go from up to xn minus 1 minus f starting from the second value, we go up to the last value divided by the first value minus the last value, that is x minus xn, and that is equated to 0. So when it is equated to 0, first value we get fx comma x0 x1 up to xn minus 1 is equal to f x0, x1, comma up to xn and xn only. Then we get on the left hand side f x x0 x1 up to xn minus 1, that is equal to the x the x0 up to xn minus 1 can be written as f starting from x up to xn minus 2 minus starting from x0 to xn minus 1 divided by first value, that is x, minus xn minus 1, which is equal to the right hand side value given. So from this x, x0, x1 up to x minus 2 on the left, and on the right when we take this f, x0, x2 up to xn minus 1 on the right, and plus x into x minus n minus 1 into f, x0, x1 up to xn. Similarly, f x0 x1 up to xn minus 2 can be written as starting from the first x x0 up to xn minus 3 minus starting from the next, that is x0 x1 up to the last value, that is x n minus 2 divided by x minus x n minus 2, and that is equal to the right hand side value. So in this way we can get f x x0 x1 up to x n minus 3 is equal to f x0 x1 up to x n minus 2 plus x into x n minus 1 and f x0 xn x1 up to x n minus 1. So doing this, we at last we will get f x x0 is equal to f x0 x1 plus x minus x1 f x0 x1 x2 plus x minus x1 into x minus x2 f x0 x1 x2 x3 and so on. Now on the left hand side we have the value f x x0, which can be written as fx minus fx0 divided by x minus x0. So this, when we multiply on the right hand side, this can be written as fx is equal to fx0 plus x minus x0 f x0 x1 plus x minus x0 x minus x1 f x0 x1 x2, these. So fx, x means the value what we have to find. x0 is the first value and the corresponding entry values is fx0. Then second value is first value is x0, second value is x1. So put x minus x0, first value f x0 x1 from the table. You know how to find the table. Then plus x minus x0, x the value what are to find, and then x minus x1, then f x0 x1 x2. So this way we can find derive Newton's divided difference formula. So again find the first line. First line gives us with n plus 1 values, we can fit a polynomial of nth degree, and f x x0 up to xn. There are n plus 1 values and x values which can we have to find. So this can be written as f starting from the x x2 up to xn minus 1 minus f second value to the last value, that is x0 x1 x2 up to xn divided by first value minus the last value. This is when equated to 0, we will get the second line, and this way we can derive the Newton's divided difference formula. And how to apply Newton's divided difference formula you all know, and whatever I taught in last example. So today for how to derive Newton's divided difference formula. Thank you.